Okay, so part 2 of the section 1-1, we're continuing on. When we have a fault that moves side to side, but there's nothing going up and down. Now remember back over here, the thrust fault has a little bit of up and down movement, but we also have, but mostly it's horizontal. If we come back here, if all we have is horizontal, nobody's going on top of the other guy, then this is what is called the lateral fault, okay? Now, if you have a situation where you've got compression from two sides and you have two cracks, all right, two fractures, one here and one here. So I have a hanging wall here and a hanging wall here, and this piece in the middle has the two sides that are the foot walls. And we have pressure coming up. That can cause this middle piece to pop up. And this is how you create what is called a fault block mountain. That's like the Cordilleran mountain range in the U.S. And I think we might have a map that will look at that. Now sometimes you can have a situation where you have this tension, and because of the tension it's actually separating. Like if these two pieces were next to each other, they've separated those pieces away, and now we've created that valley, and this is going to be specifically called a rift valley. An example of a rift valley in the US is Death Valley out in California. They call it Death Valley because so many people died there because there's so little water. All right, but most of the time we don't have these faults, all right? We have these folds, all right? So you can have folding occur, and that's where you have compression on both sides, and instead of cracking in here, it just sort of pops up, all right? Kind of like if you push two pieces of a paper together, the middle of it pops right up. And then this higher part of the pop is called the anticline, and then this low area here is called the syncline. An example of folding in the US, that's the Appalachian Mountains. All right, now mountains, whether they come from a fault block or from folding, they kind of have, you know, these peaks, and then they have the ridges on the side. The Appalachian Mountains are steeper, and that makes, or have more points, and that should make sense because they're just being pushed aside. Whereas the Cordilleran mountain range, they still have peaks, and they go up, but there's like a little bit of flatness to the top of them. Now, when does it fault and when does it fold? Well, first of all, you got to think about the temperature. If those rocks get real hot, you're going to fold. And just like anything else, if you have, you know, plastic and it gets warm, it bends really easily, right? If things are cold, they crack. So if the rocks get hot, they like to fold. If the rocks are real cold, you're more likely going to crack. And also the pressure. If you have the more pressure you have, the more likely it is to fold versus to crack. And on top of that, it also matters what kind of rock you're dealing with. If you have a nice soft rock, and nice soft rocks are ductile rocks, meaning they can bend easier. If they're nice and soft and ductile, you're going to get more folding because they like to bend. They're not going to want to crack. But if you have something that is not ductile, is very rigid, it's going to crack when things are pushed on it. And then also the time. If this is being done on a really short time, it's going to crack. But if you do it over a longer period of time, then the ground can fold. It's because it can kind of distribute that stress a little bit at a time. Now, we have these features in the country, and they're called plateaus. Now, plateaus, they can happen from a fault or a fold. If it is a flat-topped fold, then you can make a plateau. So you can have a fold where the very top of it's nice and flat. And remember the remember the plateau, these are like the table looking features. The top's very, very flat, and then you have, you know, ridges on the side. You can also have vertical faulting, and that is very much like this guy right here, where the fault goes and you just pop up and you have a flat top on there. You also can end up with a dome. Now, all of the types we've talked about up till now had to do with cracks in either cracks or pressure in the crust. The dome is its own little thing. The dome, woo, that got really big. The dome, this is the earth zit. This is an earth zit. Now, on your face, you get a zit because you get all those white blood cells below. On the Earth gets a zit when down below here is a big puddle of magma. So just like on your face when things swell up and you've got like the pus underneath there, the Earth can have magma pool underneath. And when that happens, you get a dome. And those domes, if they're real tall, can be mountains. And these domes, these are going to be nice and circular, right? Or you might see them as oval. Okay, they're not going to be in a line. They're just going to be, if you look at them from the top, they look like a zit. And if you look at them from the side and you cut that through, you see that here's the Earth's crust, here's the magma. Now when the pressure gets to be real big and that magma comes up here through the top, then the zit pops and it's no longer a dome, it becomes a volcano. All right, so the dome, that's our Earth zit. I know it's a technical term, with our magma causing it to bump over, and that's why we have our circulars. All right, that's it for now.